Okay. Good evening, everyone. I welcome you all for this wonderful session on knowledge sharing conducted by ACTech Alumni Association, Anna University, Chennai. Today, we have a wonderful speaker, Mr. Edwin Jenson. The topic he's going to talk about is process simulation and its application in the industry. So, Mr. Edwin Jenson is a BT Chemical Engineering graduate from ACTech, Kalapa College of Technology, with Anna University in 1991. After a brief stint in Tamil Nadu Petro Products Limited and SEEF Limited, he worked in Qatar Petroleum subsidiary in Doha, Qatar. He returned to India in 2011 and he co-founded his company Chemsys Process Engineering Private Limited, which was incorporated in 2012. Okay, and a founder and director of Chemsys Innovation Solutions Private Limited in 2019, the same company incorporated. He also founded Chemsys Learning Foundation in 2020. Dear Mr. Edwin Jenson, I welcome you to give a brief intro about yourself. How did you start your entrepreneurial journey? We are all looking forward to learn from you on this process simulation. Thank you. Please go ahead.
Yeah, thank you, Ramesh. Thank you, everyone who's participating. It's a pleasure meeting you all in this forum. I once again thank Ramesh for giving me this opportunity, and I really look back at our college, right? So we're all united here because of our alma mater, ACTech, right? So as Ramesh made a brief introduction, soon after college, I got a campus placement, very happy, joined TPL, spent 14 years there, 14 years, long years. Then I thought, okay, let's plan for a shift. Okay, so I got an opportunity in Qatar Petroleum, so moved to Qatar. Then because of family reasons, my parents insisted that I be here. Then I had my kids who were into the higher levels. So they also wanted an education in India. So I had to come back. So I started applying for jobs, but was not quite successful. Like people with Gulf experience are not favored well in back home here. Okay, maybe because of the salary or the fitment issues into an organization. So I was facing this issue. So meanwhile, I came across a group, a partnership firm that was called Chemical Process Systems, shortly Chemsys, run by two gentlemen. They were running it as a partnership. So I had an opportunity to work with them. And then we, 7 of us joined together, and then we formed a company called Chemsys Process Engineering Private Limited. That was in 2012. So, I mean, that company is still there. It's headquartered in Pune. But 2019, we split the company because strategically, Pune wanted to be in EPC field. And then Chennai, I wanted to be in engineering field. So we thought we'll split the company, and then, I mean, process engineering is still delivering EPC-based projects, and then Chemsys Innovative Solutions, we are more into the engineering part. We had to keep the engineering and training together because I mean we groom up people and then some leave for better prospects, better companies. So we had to keep the training alive so that whenever we have projects, but I mean, feeling we need people, it's better to recruit from our own trainees. So that gives us confidence on whom we are hiring. So for that reason, we kept the training division along with this. That was really helpful. We could tide over several manpower crises because we had this training session. So while doing the training, we gauge who's good, and then we give them an opportunity to work with us. So that really has helped us a lot. Why we split the company again? was because of the GST issues. So having engineering and training, trainees, like most of them are freshers, some experience also, but freshers wanted they wanted the fees to be very reasonable. So we had to go with a registration, a new company without the GST thing coming in between. So that's the reason why we have 3 companies now. So we are doing really good. Right now, we have crossed now all the 3 crises. So the business model is really stabilized now. So we have projects. We have some good projects currently working on, and we wanted to focus mainly on process engineering. But right now we are doing some piping modeling also. So we have license for AutoCAD Plant 3D. So we are delivering on piping related deliverables also. So that is the brief introduction about the company and myself. So we'll move into the session. It's an interesting topic. I'll share the presentation now. You'll see it on the screen. Well, we are going to talk about process simulation and applications in industry. So as you all know, process simulation is a mathematical model of a process which can replicate the process in the desktop. So we can play, learn, and do a lot of studies once the model is ready. So basically, it has 2 modes: steady state and dynamics. So we have demonstrated capabilities in both of these. So the applications of process simulation starts right from the conceptual phase. The conceptual phase helps us to screen processes, select process schemes to meet certain process objectives. So when we have several process schemes, process flow schemes, and we want to evaluate or screen which one is better, so we can get we can use the process simulation tool to find out which process scheme would be better from a capex perspective, from a opex perspective, and the intensity of the parameters. So conceptual phase, it really helps. Actually, what I want to insist is throughout the lifetime of a project, the process simulation helps us. So right now we'll see one application for a conceptual phase. Yes.
என்ன காய்கறி இருக்குன்னு பாத்துட்டு அதுக்கு சமையல் இருக்குண்ணா அது வாழைக்காவும்
So we have a propane and iButane stream, and probably you want to make it better. You want to make a stream that is say 70% of propane, split it. So we have 4 different flow schemes. So one is compressor, a cooler, put it in a distillation column, separate the propane and the butane streams. The other one, you have a compressor, a cooler, and an expansion valve, put it in a separator and split the streams. Flow scheme 3, we have an absorber. We can absorb the butane selectively using some absorption media, some solvent, and then separate the solvent, purify it and recycle it back and recover the propane part. Or flow scheme 4, you do the cooling in 2 stages. So one at a higher temperature, the other one at a much lower temperature, again taking it back and splitting it in a separator. So we have 4 different flow schemes. So which one is better? So from a capex perspective, from OPEX perspective, so we can do an analysis of the utility cost, the sizes of equipment, and decide on which flow scheme would help us better. So each one will have a different capital cost, different operating cost, and sometimes different purities as well. For example, in this scheme, you get about on a mass basis 66% of propane. This will be much better, I believe. No, not really. This, yeah, the same 66%. 67. So small changes in combustion, but the equipment configuration is different. So so in a conceptual phase, we'll face, I mean, chemical engineers face situations like this. So we can really use the process simulation tool to help us to find out which flow scheme would be a better choice. So this is about the conceptual phase application. During the engineering phase, we face even more challenges. Like engineering phase is where the process simulation tool is put to its maximum use, or we derive the maximum benefit when we enter the engineering phase. So first one is the property estimation. As you all know, properties, if the properties are right, the sizings are right. So the correct properties will give us the better sizing and accurate performance. So so engineering phase, it's rather difficult to estimate properties from lab data or retrieve it from standard textbooks or data books. So, process simulation software can find out properties at different pressure temperature conditions using different thermodynamic models, and those numbers are pretty accurate. Let's see one application for that. Let's work on a water stream. Certain properties are quite clear. We might know them, right? So we're talking about water at 30 degree and a pressure of 2 bar. So here we get a lot of properties. So right from densities, enthalpy values, heat capacity values, viscosity values. So you get a lot of property for pure components. So these are very authentic data which can be used for the sizing of equipment or when you are doing a calculation. So when we have mixtures to handle, so this is a this stream of propane and butane. Again, when you have handled mixtures, properties are even more tougher to calculate, but the software does it with much ease, and the numbers are again authentic and accurate. And then sometimes we might have situations where we do not know the composition, say like crude oil. We do not know what components are there, or with even vegetable oil. So when we do not know the components, the software gives us an option to simulate the stream using hypo components. So in this case, so this it blends a lot of hypo components, but resulting in whatever parameters that we plug in when we one second. The bulk properties we try to match. Say I know the crude oil has a molecular weight of 300, density of 783.3. I know certain viscosity data, and then I know what is the light and composition, because these are easier to determine in the laboratory. So with these minimal data, we can really create an assay, which really means that the assay is a lot of hypocomponents put together, but together, put together, they meet the input that we have given. That means the list, the software identifies the hypocomponents, assigns certain quantities, mass for the stream with a composition such that if you put together, you get a molecular weight of 300 and whatever density you have specified. So we can use the tool for property estimation, not only for pure components, for mixtures, and even for hypo components or streams where we do not really know the composition. So here it has estimated or it has blended several hypo components so that the property value that we have given matches. See, the molecular weight is 300 now. So it really helps a lot to model systems where we do not really know the composition and the components. So this is one area where the software helps us a lot. We can do HMP, heat and mass balance. This is one routine application for the process simulation software when we want to do a heat and mass balance, which as you know is the very basic process deliverable. So we can use the process simulation tool. This is a propane refrigeration loop. You can see the equipment configuration and the temperature pressure conditions at each and every location. So we can also add a table here. Okay, so the table is going to show us every stream, the temperature, pressure, mass flow, heat flow, and all that. So a PFD with stream data can be easily generated using a simulation tool. And another critical area is estimating the number of stages for a given separation. So let's try one here. So we have a column here. The feed is benzene and toluene, and we are expecting a purity level of 99% benzene. Okay, so if we want to, we want to know how many theoretical stages are required. Okay, so this is where we do the simulation. We can fit in the requirement in this page, and then we can find out that we require about 8 theoretical stages at this given pressure conditions, and it also gives us the temperature profile, pressure profile, and also an estimate of the composition in each and every tray. So this is a critical information for the column vendor. So these outputs are given to the column vendor. So they do the column hydraulic sizing based on this. And during engineering phase, we can use the simulation software for sizing of equipment as well, preliminary sizing of equipment. For example, we have a distillation column again. Yeah. So we have a column here with supporting overhead section. So it gives the, we can do a quick sizing of the column, and it says that section diameter is 1.5 meter. So for this feed rate and operating conditions, we need a column of 1.5 meter diameter. It predicts the flooding limits and many other parameters relevant to a column. So preliminary column sizing can also be done using the simulation tool. And finally, we can do a lot of hydraulic studies. So hydraulic studies are about pressure drop calculation. Recently, currently we are doing one project for a company in Hosur. So they have a very complex network of the thermic fluid system, and they find it difficult to estimate the pressure requirement at the pump. So we are helping them doing a hydraulic study. So these are typical application areas in the engineering phase. Now we move to the next phase, commissioning phase. Commissioning phase, we can really make use of the tool to standardize operating procedures. So we can really virtually start the plant. If we have a dynamic model, once we develop a dynamic model, we can virtually start the plant, shut down the plant, and then find out if at any point of time whether we are deciding, we are deviating from any design limits. So we make sure that standard operating procedures don't exceed the design limits. So the software can really help us predict and then help us to evolve the standard operating procedures. It can be used for operator training. Process plants are very expensive to build. So a new novice, we give the plant to a new person to operate, the risks are a little higher. So it's better to get them trained in a virtual model, model or OTS model they call, operator training simulator model. So once the operator is familiar with the startup shutdown procedures, emergency procedures, so and once he's successful in the tests, then we can put him in the plant to handle the live plant. So we minimize the risk by training the operator with a virtual plant. They call it a digital twin of the plant. So we can minimize startup time. Typically, control loop tuning. We are going to show you some information on that. The control loop tuning takes a long time. So if you have a good dynamic model, we can really find out the tuning parameters, and then 99% of the time, these numbers are going to work in the actual plant. So it can really help us minimize the startup time of a plant. And obviously, it can be used for troubleshooting deviations. It's during the commissioning phase that people wonder why things are not working as the design. There can be multiple reasons for that. So a simulation tool can be useful in those areas where we can find out whether my reflex flow meter is working properly, whether the reboiler is working correctly, whatever is the column performing properly. So troubleshooting, it can really cut down on the experimentation that we need to do in the plant. If you do your homework in the simulation software, the troubleshooting in a live plant is going to be much easier and much safer as well. So we'll show a couple of applications for the commissioning phase. Dynamic simulation. Yeah. So let's see compressor startup. So a compressor has two limits called the surge limit and the stonewall limit. So the black line is the operating trail, right? The operating point from a static condition when you roll the compressor on. So it moves on, it crosses certain flow head combinations, and then you can really see from this image that this compressor has gone into the stonewall limit. This is called the stonewall curve, and the pink one is called the gray one on the right border is called the stone wall curve, and the pink line on the left is the surge limit. So we can see that if we follow this track or this startup procedure, it violates the stone wall curve. So let's see one where it has been done properly. This is much worse, right? Let's see one more. Oh. Yeah. So we tune up certain control valves, and then here you see really the operating curve quickly reaches and operates within the limits of the surge curve and the stone wall curve. So we can really save a compressor if this study is done beforehand. So we talk about the controllability, the pretty big picture. So we have the very big flow sheet that we developed for the company in Azerbaijan. So there are a lot of controllers put in, right? So we did several trial error connecting this parameter with that parameter, and then we found out which control scheme would make the system work better, help in startup shutdown. So for controllability studies also, we can use the software. And this is one another application. It's called the surge pipe surge modeling. So the background is, if you have a line through which a liquid flows and suddenly somebody closes the valve, so it's just like applying sudden brake on a moving train. Okay, the train derails. The same way, the momentum, the energy transfers to pressure energy, and huge surge in pressures are seen. So this is called the pressure surge. If you see, the line was operating at around 2 bar only. It has reached 10 bar instantaneously just because somebody closed the valve. So now, if my design pressure of the piping is not that high, then we may have to we may have to modify the process so that the design limits are not crossed, exceeded. So a pressure surge study can also be done using the process simulation tool. This is a PID tuning. You can see it live here. So look at the the screen here. Yeah, so much of fluctuation in the blue line, right? So the controller is struggling to maintain the level in the column, in the separator, right? It's moving up, down. It's because of the wrong PID values, tuning parameters. Now, suppose we change the tuning parameters. You'll quickly see that the flow tries to stabilize. Doing it in a live plant is very, very risky. So optimizing on the PID parameters, if it's done offline in a dynamic model, and once we do this, so we take this numbers. So right now we change the, there was 3 values here. KC stands for the proportional, TA stands for the integral, and TD for the derivative. So we removed the integral and derivative because it's a simple separator level control, and a little offset here and there is not going to matter much. So we just tuned the controller using only the proportional constant, and you can see that the fluctuation really stopped. So when we have, say, hundreds of controllers to tune in a live plant, it's going to take a lot of time, and then sometimes you can really upset the plant. So if you don't want to do that, then we have a dynamic model built, and we find out the parameters that would work, and most of the time these numbers are going to work perfectly in a live plant. So this is one area. And then so this was one project that we did for a company here. So it was a ethylene oxide unloading scheme. So it had a requirement of bringing down the cargo. The ethylene oxide is brought at a higher temperature, but the requirement was it has to be brought to a lower temperature within a certain time span that was specified by the client. So the requirement was to find out what would be the duty of this. I mean, calculating it manually is a little tedious because every time the inlet temperature changes. So when this scheme is on circulation, so every pass it takes through the heat exchanger, the temperature drops. So eventually the inlet also changes. So I mean, and added to that, you have a unloading going on, consumption going on, several parameters affecting the dynamics. And still, if you want to accurately estimate the duty requirement or size the heat exchanger, so we can do a dynamic simulation and then get data from that. So dynamic simulation finds several applications. So we have done several projects on dynamic simulation. So many live plant issues we have worked on using dynamic simulation. And then we can even do plant optimization studies. Let's see one demo there. We have a feed of it was a textbook problem only, tetrahydrofuran and toluene, and then we are operating the at a purity level of 99% of THF and toluene, and then we built a Excel sheet here, a spreadsheet here, finding out the cost and the profit. Okay, so cost is the feed cost. Capex is not done here, but the operating costs, the feed cost, and the reboiling and condensing utility costs have been added. And the revenue is from selling the overhead product and the bottom product, that is THF and toluene. So as we all know, higher purity will fetch a higher price, but getting higher purity will result in higher utility cost. So what would be my optimum? So right now we have converged this column based on 99% purity of THF and toluene, and you can see that we are just making about $3 per hour with this processing condition. Now, if we can do an optimizer, it has been pre-configured, so we just tell the software that hey, you change the purity between 0.9 and 0.99. I'm happy with either any purity value within these range, but please try to improve my profit. Okay, maximize my profit. So this clubs the simulation with the spreadsheet, and then we say start. So see a huge jump in profit now, $94 per hour. So from $2 per hour, which we are running at a much sub-optimized level right now. Though we compromise on purity, okay, it's 92%. The software says that if you target a overhead purity of 92 and a bottom purity of toluene at 97, okay, so given your price information, so this would be the best operating point where you can make a lot of money, $94.4 per hour instead of $2 per hour. So we can have a optimization also run along with the PFD. So we completed. Okay. So we'll go to the presentation. Yeah. So we can do a lot of process studies as well, right? We don't have a model here, but one study we did for Qatar Gas was a column fluctuation during a bed changeover when they had a absorbent vessel. So when there was some feed stream that was switching on, right, the downstream column would fluctuate a lot, and the pump would starve, and then they were facing a lot of mechanical issues. So there was a proposal from UOP for mitigating this. So they wanted to inject a paraffin into this, a limited quantity of paraffin, and see if it would mitigate the fluctuation in the column level. But they wanted to try it out in the software before doing actual implementation. So we did the modeling for them, and then we confirmed that the level fluctuation would stop. We found out the revised operating conditions for the column, and that was quite successfully implemented as well. So it's like a backbone. Okay, it's like a backbone where we can use it throughout the life term of a project. So this we have seen already. We can use a dynamic simulation for startup shutdown of the plant, modeling it, finding out if we are increasing on the limits, design limits. We can evaluate transient conditions. For example, I'm switching over feed from grade A to grade B. How much long would it take for the overall product to reach its earlier purity? I have a feed upset. How much long would it take to get normal? Or even for safety valve studies. So when my reflex control valve closes suddenly, what is the column relieving load? So those are transient conditions which can be modeled using dynamic simulation, and then taken into a safety valve sizing tool, and then we can size the safety valve. We've seen compressor surge analysis, pipeline surge analysis, controllability studies involving the use of the cascade controls, or overall controllability of a flow scheme. And then we also talked about the PID tuning parameters. It can also help us to arrive at the safety relief loads. So these are the software in the market. So we have ChemCAD, DWSim, which is open source. Promax is there, Pro 2, Aspen HYSYS, Aspen Plus, and Honeywell Unison. Honeywell Unison is the one we have license for right now. So all the demo was shown to you using Honeywell Unison. So both HYSYS and Unison are popular in the market, and Unison is much better for dynamic applications. Okay, so that brings us to the close of this presentation. So, if you're new to the tool, we suggest that you learn the software. It really helps a lot. It makes understanding chemical engineering very easy. Okay, so we can just play with the numbers and see how things get affected, or what parameter changes what to what extent, right? So if you already have the tool, we encourage you to use it, explore it, because lots and lots of options. Every day we learn a new thing when we try it out of the software. Right now we are working on a stabilizer column for a plant here. So we are trying to match the PFD data. So everything is a new learning with the software. So you can contribute to the this process, right? You can if you know an opportunity where you think a software can help, right? So we can work with this. So you can also do a case studies and then share it among the community, and also you can collaborate doing live projects. So really thank you for the time here and your participation as well. So over to you, Mr. Ramesh.
Thank you, sir. Really appreciate the presentation. It was really wonderful. Always you make this tough topic so elegant and simple to understand it. So real sincere appreciations. So I'll ask the participant to share their questions. So they can unmute themselves and then they can ask the question directly to you.
Sir, good evening, sir. Myself, Balaji.
Yes, Balaji.
Regarding the process simulation software you told, sir, like Honeywell, Aspen, Pro2, Promax, and USIM, ChemChat. Which software is the best suitable for what kind of application? Which software we have to use for what kind of that is what kind of process? Can you explain this?
See, for oil and gas, things are quite clear. For oil and gas, Aspen Hysis or Honeywell Unisym are the best. Okay, not without much challenges. So quite a straightforward application. But when we have polar molecules, okay, so it's basically regarding the type of components that we are dealing with. So when we are dealing with tough components, when we say tough, when we are dealing with non-ideal behavior of components, or we have polarity involved, when we have electrolytes involved, or we have solvating components, or components that interfere with others, right? Polymers involved. When we enter into those areas, then we need special property packages. Of course, NRTL is there in Honeywell Unisym, and it's part of Aspen Hysis also. But NRTL, it can help us with certain non-ideal situations. But when there is too much deviation from ideality, right? So Aspen Plus would work much better. That's the bottom line, right? So Aspen Plus is for tricky situations, very complex things, and the straightforward applications we can go for Honeywell Unisym or Aspen Hysis. DWSIM is an open tool, should be really helpful for freshers, right? So it's developed by a guy from Brazil, right? So we can use it, but the solving a flow sheet takes a little more time and it's a little more challenging with DWSIM. Does that answer your question, Balaji?
Yes, sir. Thank you, sir.
Any other questions? Sir, I have a general question. In fact, we just had this chemical engineering and petrochemical engineering syllabus committee review for chemical engineering departments. In fact, one of the discussion was about process simulation and dynamic simulation, included as part of a core subject. Someone was telling it should be an optional or elective, but we insisted this is one of the important aspects for chemical engineering. So we ensured that it's part of the main subject. Now, the question they have is, even for the private engineering colleges, whether they can afford this software, right? One is the affordability of the software for the students to practice. The second one is, how can we bridge the talent gap, even the teaching faculties, because the faculties, many of the faculties have never seen the elephant actually, right? So if they have the industry exposure, they can teach better to the students. So in that type of scenarios right now, I'm not generalizing, but few colleges. So how can companies like yours can help to bridge the knowledge, to give the right teaching to the students, so that they equip with this tool actually? right? Because the other aspect is like, Chennai has become the engineering hub of the world, slowly. Many of them do not know they have plenty of opportunities for chemical engineers, including flow assurance, those type of jobs. It's vital that the students are given the right skills on this element. Could you throw some lights on that?
Yeah, Ramesh. It has, in my opinion, in my humble opinion, it has to be made a part of the UG syllabus, and it should be made compulsory. It should not be an elective. Earlier, I remember when I was in college, simulation or modeling, process modeling was an elective, but in my opinion, it has to be made compulsory. Now, training the teaching faculty. From Kansas, we have conducted several workshops. So we have conducted this in NIT once, DIT several times in Trichy. So here, several colleges in Chennai also. Kumaraguru we have done. Colleges are open to engaging us for training their faculty and students. So
So are you finding it challenging to go and teach these to the students, or how receptive students are about this particular course?
So again, see, there are about 10-20% of the people, students who are really very interested in the topic. It's just like anything, and there are bulk of people who have already lost their direction. So 50-60% are, they have lost their direction. Okay, and of course the balance 10-20 not interested. So this pattern we see in almost all colleges. The idea, every time we implement, whenever we go to a college, we try to pick who are waiting for direction and show them that there is a big opportunity in areas like this where we can really really work on a higher knowledge level, not as a this team of the majority at the middle. They have somehow got convinced that you'll find a work as an operator in a pharma company that is guaranteed. So that is the mindset with which this middle chunk is there. So we want to we try to motivate them, encourage them to learn tools like this, and then take a diversion towards learning such tools and then using it for their future. For faculty training, what we have found out is, I'm not again pointing out at fingers of someone. Faculty, one, they are pressed to their limit. Okay, they not only handle academic, most of them as they reach senior positions, they are handling the so-called affairs, right? they not in the academic, they handle the department. Many administrative work. Yes, administrative work. So they sit for 2 minutes, then get a call. They go there, come back, they're lost, right? So they can't sit for a day. Typically, we conduct workshops for 5 days or 3 days, depending on what coverage they want. So making them sit in a place for 3 days is totally not possible. So they first class they attend with all attention, then they get diverted. I have some paper corrections, sir. I have some this thing to do. So the whole thing is lost. So if they are taken out of the campus, put somewhere else, and then if training is arranged, is definitely going to be beneficial for them. So they will have to be cut off from the college environment. Students can be trained in the college environment because generally they follow discipline. So in the buildings, you can expect them, most of them, to be in the class. So conducting a workshop like this for students in a college is not a problem, but for faculty and even for planned people. So I generally think that they should be away from the workplace, dedicated 3 days or 5 days, so that they can learn the tool patiently without any interruption.
Okay, sir, excellent. Maybe you should organize these sessions in like Pondicherry or type of resorts so that people are away from their regular works to come and attend the course. Okay, sir. So, is there any
There is
other
interesting,
questions?
there is an interesting forum called FOSSE, FOSSE. So people who are interested can visit this portal, and they are collaborating with DWSIM. So you can find out several flow sheets which have been already solved and uploaded by students and enthusiasts. Okay, they've all uploaded such process flow sheets in the and then it's quite effectively coordinated by IIT Mumbai in India. So students can get in touch with FOSSE to get benefited more about process simulation tool without spending much money using DWSM.
And then the industry perspective. So now they have the plant experience, like like Balaji, I assume he's in tech services in Kotari. So how can they do this type of simulation, and they can fine tune their plants on a regular basis? Like normally, if there is any studies type of thing, they would come to experts like you. But as a technical services person, how can they do the fine tuning of the plant process operations? I know you already mentioned few other items. In day-to-day activities, how can they use this type of solutions?
So one suggestion I would like to make for operating companies is to have a digital twin of their plant. Okay, so this is one-time job. They will definitely have to have a digital twin. Okay, so that will make their technical services department to work much better way rather than dig around for data. Trying things out in the plant. So if you really have a digital twin built, nothing like that. That is going to be of immense help to the technical services department. Unfortunately, nobody is showing interest in this area. Okay, though we have the tool, we have the capabilities, talent, and we're not seeing people open to this concept of a digital twin. So I really encourage operating companies to have their plant model in a software so that they can always troubleshoot, do some studies, improvement studies, so that can really save them a lot of money.
Thank you. Thank you, sir. Any other questions, please? Yeah, the participants can introduce themselves and then they can ask questions. Mr. Velmurugan, you have any question?
Yes, Ramesh. Actually, Mr. Edwin mentioned that, okay, operating companies should use this software, but the big concern is like the cost. If it is feasible, people don't mind using it, but it goes in the form of, say, 10 lakhs, 12 lakhs, 15 lakhs. So naturally, people would think of what is the payback and how it's going to be feasible for small scale industries purpose. Okay, forget about big industries. They have this all softwares in house, and they are using it possibly. For the small industries, how it would be feasible to get it installed in their process engineering service and usable. Edwin sir, do you have any good suggestions to go ahead with this purpose?
Yeah, Murugan, you you nailed it actually. See, these softwares are very expensive. They have different licensing patterns, targeting different user groups. For colleges, it's the cheapest. Okay, so I think you pay a couple of lakhs, 2-3 lakhs, you get 99 licenses and sometimes 150 licenses. That is exclusively for academics, and they get you in writing that you will not use it for any industrial use. But for industrial applications, um, they have again a couple of licensing patterns. What we have is a machine logged one. This is logged to one machine, so that means it doesn't have any portability. So if you want to take the software somewhere, you'll have to carry the CPU with you. So this logged up or logged machine logged application costs somewhere around 10-12 lakhs. Okay, and then depending on what options we choose, it can go up to 18 lakhs per annum. Okay, and then I mean, you have network licenses and several other token-based licenses. So those licenses are available, but as you rightly said, it's an expensive option. And the only other way is to try to build your model in open source softwares like DWSN. If you find out the appropriate model, then it is going to help you a lot. That doesn't cost you any money, but you should be lucky enough to make your model in open source software. Okay, it has a lot of limitations as of now. They are continuously improving it. We have even we have tried several models with them, but if you are really lucky to model your plant in an open source software, then you can do it with no cost. But whenever we attend a demo or a webinar by Aspen Tech or Honeywell, so most of the time they show a cost benefit analysis, right? Where always they show that it's nothing, it's peanut actually. They show that the saving making a marginal improvement in the process. So it really several times, it returns several times your investment. That's what they showcase every time we attend a webinar. But maybe we haven't got an opportunity to demonstrate to that extent, right? But having a cost constraint is a known factor in the industry. And as you rightly said, returns, unless you use the tool, you have to use the tool. You'll have to squeeze the tool so much. Okay, it's not having the tool that is going to benefit. See, whenever I complain to Aspen Tech, 4 years back we were using Aspen for about 6 years. So every time I tell them, see, your software is very expensive, they simply laugh. They say you do not know how to use this tool, and they feel sorry that we are unable to use the tool. They say you squeeze the tool so much that you can really save several millions, and then never worry about this cost at all. So that is how they try to see the same issue. So from our side, we think that it's expensive, but actually from their perspective, they feel that if you really squeeze the software and make the best use of it, actually they are selling it to us actually at virtually peanuts.
Yeah, actually, as you said, once you start using it, you will feel the real impact of the
Exactly.
benefits actually. But people just have a lot of resistance towards to invest
Yes.
the initial money. That's
Exactly.
that's where the real challenge lies actually.
Mm.
So, but for the engineering companies, by hook or nook, they have to go with this software part. But the operating companies is the real challenge to get into it.
Mm.
So, but
So
once,
operating companies can tie up with companies like us, and then they can they can work on it. So
that
that's
is
another
good idea actually. That is a good idea.
Yes.
Okay, right. Thank you.
Thanks.
Okay, sir. So it's already 1 hour past. Thank you very much for this opportunity, sir. I know we really appreciate your taken time to come and present it to the alumni and as well as to the other participants who are interested to join the session. Thank you all. You all have a good weekend, and then make sure you watch the Olympic closing ceremony from your TV. Thank you so much for joining, sir. Thank you. We'll record we'll upload the session, the YouTube, and we'll share the link.
Okay.
Thank you. Thank you all.
Thank you. Thank you.
Thank
very
you,
much.
Ramesh.
Thank
It
you.
was really nice time being here.
Thank you, sir.
Bye.